We see objects exert force on each other in the physical world, and this gives us fancy patterns like this. Now, mathematicians, when look at the numbers on the number line, a thought that comes to their mind is that, are there repulsive forces between the integers? Why are they equidistant? If there exists some kind of force, then what's the magnitude? Now, in late December last year, the mathematician Vasilin Dimitrov posted a proof online. The proof was of the Skinzel-Zassenhaus conjecture. This actually deals with the geometry of values of the polynomials. It predicts a particular pattern which certain values follow when they are graphed. Now let's talk about roots of equations. Have a look on these equations. Is there something in common in them? Yes, they all lie on the circumference of the unit circle in the complex plane with center at 0 plus 0i. These particular equations are called cyclotomic polynomials and can be used to frame other equations as well. Now, in the year 1965, the mathematician Andreas Skinzel and Hans Zassenhaus predicted that the geometry of the roots of cyclotomic and non-cyclotomic polynomials vary in a very specific way. Try to plot the roots of any non-cyclotomic equation. You will see that some roots may fall inside and some roots may fall outside the unit circle. This conjecture actually tries to state that some roots inside the unit circle actually pushes the other roots outside the circle. In a clearer version, it states that every non-cyclotomic polynomial should have at least one root that is outside the unit circle by a distance equal to a constant divided by the degree of the polynomial. For the next few decades, few improvements were made on this particular conjecture until Dimitrov used the concept of power series. With some specific properties like all the coefficients must be positive or negative integers. And in November 2019, Dimitrov realized that by using some well-known theorems, an association can be established between the roots of the non-cyclotomic polynomial and the power series. He finally proved that all non-cyclotomic polynomials must have a root that is at least log 2 divided by 4 times the degree of the polynomial outside the unit circle. This obviously satisfies the conjecture.